Hello friends, welcome back to Max Lecture Series. In this series, we will be learning how to solve various fields under various integrations. Of course, we are in vector calculus, we are learning how to utilize Green's theorem, Stokes theorem, divergence theorem in order to bring the answer for vector field under integration. Now, if you observe the given function, given it is v vector equal to del cross a vector, then which of the following is true? Simply they have given the question here. Now, remember one thing, whenever a field will be represented with this arrow mark v on the top, if you observe the arrow mark, then that is called vector field, representation of a vector field. It will be equal to del cross once again a vector field. They have given the relation like this. After that, if you observe all the option, they are bringing the relation between line integral to surface, line, surface, line, surface, line, surface again. Now, we understood line integral means we will be talking about line to surface integral means we have two theorems. One is Green's theorem, another one is Stokes theorem. Because divergence theorem basically dealing with the surface to volume. In the last class also we are observed that, see there, this is Gauss divergence theorem. Basically Gauss divergence theorem dealing with the surface integral and volume integral. So we are not going to consider Gauss divergence theorem here because we are not going to bring the relation between surface to volume. Here all the given options are line to surface. Now if you observe, go back, let me tell you, already we have been observed that there are two theorems. See, one is Green's theorem, this is Green's theorem, and we know how to observe the Green's theorem. In line integration, if the given function will be in this format, m into dx plus n into dy, then we can convert it into surface integral into this format, dou n by dou x minus dou m by dou y into dx dy. But if you observe the given option, basically they are bringing the relation between curl v vector and del cross. So curl means immediately only one theorem is there with us, that is called what? Stokes theorem. That is also we have been observed. See there, this is basically called Stokes theorem. We already observed one more theorem here, that is called Stokes theorem. So Stokes theorem basically helping us to bring the relation between line and surface, of course in terms of curl. And see, this is closed integral only. We are traveling from closed to open surface. So here this can be written as closed integral of f dot dr equal to f is a vector field only. This can be written as curl of del cross f vector into ds vector. So here we understood that out of these three theorem, the given relation is talking about which theorem? Stokes theorem. So just now we understood that Stokes theorem can be written as, we can consider a vector field with respect to, see, line integral. This can be transformed into surface integral, that is open surface. Here we can convert, it should be converted into the form of curl, that is del cross f into surface integral ds. We can write like this. Now with this we have to identify the answers. If you observe in this single line, see in the line integral we have in place of f they kept v and they kept a, and in other places they kept del cross v, del cross a. These kind of things are not possible. In single integral we will be having only simply field. After that in the surface integral it will be converted into the form of curl. So either we must go up with the option A or option B. Which one is the correct answer here? Now let me take, suppose if you are going up with the option A, in the option A given it is v vector into line integral dl. How will you convert it into surface integral? It can be converted into the form of del cross v vector into ds. Shall I write like this? Yes. Now if you observe, see there, del cross v can be converted into del cross v. Can I replace del cross e vector by a vector? No sir, the given relation, if you observe, the given relation is v vector, del cross a vector can be replaced by v vector, but I cannot replace del cross v by a vector. So this relation is absolutely, if I will replace it by a vector, then that is wrong, because this type of relationship will not be given in our question. Then what is the correct answer? Let us go ahead with the option B. In the option B, what they did is they have taken simply a vector with respect to line integral. Then this can be converted into surface integral, and I can rewrite this one is del cross a vector into surface integral ds. Can you replace del cross a by v? Because see, in the surface integral they have replaced the resultant answer by something. Yes, it is possible, because according to the given relation, del cross A vector can be replaced by V vector. So I am replacing this surface integral can be further written as V vector dot ds. So what is the correct answer? Line integral of A vector dot dl vector can be written as surface integral of V vector dot ds vector. So the correct answer is option B. So always we have to be conscious. The questions are very easy, but it is very important to learn how to apply our theorems. This is all for this lecture. In the next lecture, we will be coming up with one more question. Thank you all.